Hi, everyone. My name is Jeremy McLaughlin. I'm an associate at K&L Gates. K&L Gates is a global law firm with about 2,000 attorneys and 50 offices around the world. I'm based here in San Francisco. I'm in our consumer financial services group, work a lot with fintech companies, ranging from startups to some of the largest banks, and some of that work includes advising them on regulatory compliance issues as they implement blockchain technologies. So you are not here really to listen to me, so I'll introduce the first of our speakers. The first is P Andersen. He is an electrical engineering and computer science PhD student working on technologies for smart cities. His research covers wireless sensor networks, time series databases, operating systems for the built environment, and secure communication infrastructure. Recently, he has focused on blockchain smart contracts as an engine for managing authorization and trust at a global scale, especially for the Internet of Things, without relying on a central authority. Michael?
So I picked this to talk about because we've been working in blockchain technology for about a year and a half, since Frontier release of Ethereum. And this has been, we've been through our own internal hype curve, and this has been the application that is kind of after the hype curve. After we were like, wow, blockchain is so cool, we'll do everything with it. This is the one that actually stuck that we could not have done full stop without blockchain technology. So the problem is, especially in IoT, but all around you, authorization is centralized. You trust Google to manage the lists of who's authorized to access various things. You trust your device vendors. When you buy your smart home devices, your thermostat talks to the cloud. Everything around you is talking to the cloud, and all of that authorization of who can access what is all stored on those vendor servers in the cloud, or it's federated done by Google, Facebook, and whatnot. And the problem is, in this global Internet of Things, if this is all centralized, who can you trust to be that one central point to manage this list of authorization? And the point is you can't. Even if you could trust these organizations, it's still a central point of weakness. If there's one party authorizing the world, that means that there's one place that needs to be compromised. And the organization as a whole might be good, but it takes one disgruntled employee, one lost USB drive, one lost laptop to compromise all of that. So our question was fundamentally, is this necessary? Is it actually possible to build a completely trustless, decentralized, and democratized authorization system? And so let's just break this down. What does this mean? So firstly, trustless is that there's no implicit or mandatory trust. For example, if I'm using federated identity by Facebook to authorize something, then I have to trust Facebook's management of those ACLs, because that's mandatory. Like I can't interact with the system without doing that. So can I get a system where I can control, to my own heart's desires, exactly who or what I trust? The second is decentralized, that there is no single data center or organization whose compromise could break the entire system. And democratized is that everyone is equal, that anyone can grant any permissions to anyone without going through an authority. So I don't have to pay some authority to do something, and if I fall out of favor, I can't have my ability to participate in the system removed, I can't be censored or restricted in any way. And so we built a system and had this deployed for about a year to use smart contracts to achieve this. And this is the executive summary because there's a huge amount of crypto that goes into a lot of the claims that I'm making here, and I can refer you to a paper later, but essentially it comes down to three things. Every device, every service, every person participating is an entity. It's essentially a key pair that they can use to sign things. This is the principle in the system. Then you have resources, which are the things that you grant permissions on. And these are grouped into namespaces, which are controlled by these entities. And the cool thing here is that anyone can create a namespace and then become the authority within that namespace. There's no authority that restricts this. And to grant permissions, you create this delegation of trust object that says this entity is granting the following set of permissions on the following resources to another entity that gets signed and put into the blockchain. What's really nice is this is kind of leveraging a lot of the whole public key infrastructure web of trust model, but because it's in a blockchain, you get much stronger guarantees because you can get a proof of non-existence, which you couldn't do before in DHT or peer and key server-based systems. I can know for sure that this proof that I'm given, that is a sequence of delegations of trust that shows that from the namespace entity, which has complete permission to resources within that namespace, to the person doing the proving, sending the message, it shows that path, and I can know that there does not exist any revocations or any expiries or anything there, which is not something we could have gotten before. And furthermore, this can be verified with no communication. When a device in your home receives a message with this proof, assuming that it's participating in the blockchain, it doesn't speak to any authorization servers to validate this message. So there's no servers to compromise to make you accept fake authorizations. And the implications of this system is that you can only interact with resources you've been granted access to, irrespective of if servers in the core are compromised. Even if the server routing the messages is malicious, that server cannot forge messages or cannot read messages or cannot do anything. That granting and verification of permissions is all done without any interaction. I don't have to speak to you to grant permissions to you, which means I can grant permissions out of order. And this all achieves a global, consistent view of authorization. No central coordinator, no central point of weakness. There are also some more interesting implications, is that this is actually impossible to tap. Even if you control all of the infrastructure, because of the crypto systems we're using, it's not actually possible to tap any of this, which is actually legally required in some countries that they can, so that's interesting. And also, this entire system doesn't address the binding between an entity and an identity. Devices and services and people have entities, but if I want to bootstrap my trust of you because I know that you're some person with some name and some country working for some organization, that has to be taken care of. And there are other systems you'll hear about later today that look at identity and solving some of this problem in the blockchain. So that's kind of the high-level overview of the work that we've done.